Okay, absolute value equations. Okay, let's jump into these. Kind of review here. So let's kind of jump in and look and see that we're going to be solving absolute value equations and solve absolute value equations with two absolute value equations. Okay, let's remember that the absolute value of a number is its distance from zero on a number line. Okay, let me draw a little number line here. If we come over here, got a very weird slanted up number line, so we're kind of my number lines on a hill. If we got 0 here, notice if I can go in this direction, I can have, let's say, 7. But if I go in the opposite direction, I have -7. Notice how I just denoted that. Direction. Direction can be denoted as positive and negative. But if we look at this, how far am I from 0 in either one of these situations? And no matter what, I am 7 away, which is why the absolute value of a number is its distance, which means it cannot be a negative. Okay, distance cannot be negative. Okay, so for any constant greater than 0, okay, if the absolute value of x is c, then you can have two values. X can be c or -c. That's what we just saw. Notice I just said if one could be 7, okay, then it could be 7 or -7, okay, because we're talking about the distance, okay. And then this right here is just if you have an expression, okay, that's inside the absolute value, that you're actually going to have two answers. Instead of just solving for one x now, we're going to be solving for its positive and its negative, okay. Note if the absolute value expression is isolated on one side of the equation, we say the equation is in standard form. You may need to manipulate the absolute value equation to get it into standard form before you solve it. Let's see. Now, I think I might have done that one as an example. We'll see. Okay, let's come in here and start doing some of these. Okay, solve each absolute value equation. Well, for the first one, we have x, the absolute value of x is equal to 5. Well, let's remember, as our definition says, you can have two answers. You will have two answers. So whenever you have x, the absolute value of x is equal to 5, well, what could x possibly be? What could actually be something that would give me a distance of 5? Well, when you think about it, if I thought about this on a number line, where could I be? If I'm going from 0, where could I possibly be? Well, when you think about it, a can either be 5 or -5. So that's what x could equal. Because remember, we're just looking at distance here. Okay. Now let's look at b. Well, I have 3x minus 4 equals 5. So remember, going back to our definition, we can have this equal to 5, or notice here we got a -5. So let's come in here and write that both ways. 3x minus 4 equals 5. Okay, we could also have 3x minus 4 is equal to -5, and solve for both. Add plus 4 to both sides, okay, and then I get 3x is equal to 3x is equal to 9, divide by 3, and then you get x is equal to 3 on one of them, and then do the other one. Now I've got a plus 4 here as well, plus 4 there. Well, -5 plus 4 is just going to give me a -1, so that's going to be 3x is equal to -1, divide by 3, and so x can also equal -1/3. Okay, so there's both your answers for B. You plug either one of those in and it works just fine. Okay, let's continue on here and let's look at C. I'm going to come up here kind of high for C because we don't really need a lot of room. Because when you think of this conceptually, I said distances cannot be negative. Well, look at what we have right here. How can I ever have a negative, no matter what happens inside here, okay? I cannot have a negative out here. It cannot be equal to, it'll never be equal to a negative, okay? Can't happen, okay? Because distances can't be negative. Now, I don't want you to think that here, well, you got a -1/3 here. Yes, but that is what's happening inside the absolute value, okay? Not out here. So remember, that x is inside the absolute value. So here, it's right here. No solution is probably the best thing to put. That's probably what Hawks is going to tell you to do. And then now we've got D. Okay, D Notice you have to get the absolute value by itself first. So when we do this, we've got 5 absolute value, 3x plus 17 minus 4 equals 51. Okay, do not treat this to where you think you can go ahead and start distributing. Okay, it doesn't work that way. You can't distribute into an absolute value. You need to get it by itself. So I'm going to add 4 to both sides here, and that's going to give me 5 absolute value, 3x plus 17 equals 55. Divide off the 5, and then I get the absolute value of 3x plus 17 is equal to 11. But not just 11, I can also get 3x plus 17 is equal to negative 11. Well, then we can go ahead and just solve, and I've got a minus 17 here, minus 17. We've got 11 minus 17, and that's going to give us negative 6. So we got 3x is equal to negative 6. Divide off the 3. Okay, and one of my answers for this one, I'll put it right here, x can equal negative 2. Well, what's my other one? Well, let's do another 7, minus 17, minus 17, and that's going to give me 3x can equal, what is that going to be, negative 28. Divide by 3, divide by 3. Okay, 28 divided by 3 is going to be a weird number, so notice we cannot simplify that one, so we get negative 28 over 3. And that's how those work. Whenever you get them in a simplified form, okay, sometimes you're not going to get this nice pretty number, but both of these x's right here will keep this statement here true. And I do apologize how things got kind of messy inside there. So definition. If the absolute value of a equals the absolute value of b, then either a equals b or b equals negative b. More generally, okay, if there's an expression equals c of, if the absolute value expression equals another absolute value expression, then either ax plus b or cx plus d or ax plus b equals the negative. All this is saying, that's a lot of word salad. I don't want you to get lost in this. This is what this means. Watch. Okay. On this one, when you have two absolute values, you're going to have, one of them is going to have to be your absolute value. One of them is going to have to be your negative. I usually just always go with this guy here. Let him be my absolute value one. Let this guy here be the one I'm going to have to change. Here's what I mean by this. And here's what that definition is saying. You have two equations. I have, hold on here. I have x plus 5 can equal 2x plus 1. Well, that's my positive version. Remember, one of these has to be positive. Or, okay, I can have x plus 5 is equal to, now here's where it gets a little weird, negative 2x plus 1. Then just solve like normal. Remember, with this one here, you're going to have to distribute that negative. Here, we're just going to solve like normal. So I will subtract an x here, subtract an x. That reduces that out. Okay? Since this reduced out here, I'm going to subtract 1 here, subtract 1 there, and then I get, that is going to just give me x is equal to 4. Okay, well that's one answer. Because notice here, these canceled out. Got 2 minus 1, that's going to be an x. Then 5 minus 1, that's 4. Okay, over here, I'm going to have to distribute this negative. So now I have x plus 5 is equal to negative 2x minus 1. Well, now we can go ahead and continue solving. Solve it like normal now. I'm going to add 2x here. Add 2x there. Okay, these guys are going to cancel. Okay, I'm going to subtract 5 here, subtract 5 from there. Okay, well, that's going to give me 3x is equal to negative 6. Divide off the 3, and I get x is equal to negative 2. So my answer here would be x could either be negative 2 or 4, and that gives me the answers I need for this expression to be true. That's in a very simplified way, stating what they're trying to tell you in that definition. It would be smart, I say smart, maybe just since you're going to be going on to college algebra, maybe go back and see how this example relates to the definition, and then that'll help you over time to start being able to read definitions a lot better. I was really bad at that early on, but try to go back and learn to read them after a while, okay? It'll help out.